right, over the next several days, you're going to talk about some different investigations, and today we're going to look at one that involves chords and arcs in a circle. So the first investigation, it says an artist plans to paint a circular mural on the side of a building. Play the animation to see how he can decide where to place the center of the mural. Just watch the animation. You do not need to do anything on your paper. So I'm going to play through the animation, and then I'm going to work through the notes and have you follow along. You will need your compass for this. So here's our picture of our building, and the mural is going to go right here. And so he knows that he puts these three dots need to be the base of his drawing. So in order to find the center, he connects those together and he finds the perpendicular bisector, which we are going to use the compass for, and I'll remind you how to do that. And so he finds the perpendicular bisector of each point, and where they intersect will give us the center of our circle. So in your notes, if you will, we are going to first, so get your compass, you're going to connect the points together. So we're going to connect these together and then connect these. All right, now we're going to find the perpendicular bisector. So if you'll remember to do this, you're going to put the end of your compass on the end of your segment, and you're going to find a point that's more than half of past the midpoint. So we're going to be using these inside points. So you really need to make sure you hold down here. So pick a point that's more than halfway. So I'm just going to pick this point, and you're going to make an arc above and below, or you can just make one complete arc if you choose. The important part is to remember the arc that you use, or the hole that you used, because now we're going to switch to the other end point, and I'm going to use that same arc, and where my arc, or sorry, the same hole, and where my arcs intersect will create a perpendicular bisector. Okay, so that is perpendicular and goes through the midpoint of that segment. So now we're going to repeat it on the other side. So I'm going to put the end of my compass. The segments appear to be the same length, so I could probably get away with using the same one. But just remember, it has to be more than half, has to go past the midpoint. And then use the same setting. Okay, and where they intersect will create your perpendicular bisector. And I'm going to need to extend this one because I want them to intersect, because where they intersect will be the location of the center of my circle. So here's going to be the center of my circle. These 3 points are going to be on the circle. So the distance from here to here is a radius, or from here to here is a radius. So I'm just going to put the center of my compass on the center of the circle, and I'm going to find a hole that matches up perfectly, which looks like it's this one right here, and then I can create this circle. And my circle goes through all 3 points, and this would be the center of it. Okay, so now we're going to look at the reason why this makes the center of the circle. All right, so it says that now that you've completed the conjecture, it says, or now that you've completed the following conjecture, this application suggests that the perpendicular bisector of the chord on a circle contains the center of the circle. So right here, we're going to put the center of the circle. Okay. And then here is our proof. It says, why do you think this conjecture is true? All right, so we're going to have to remember some things about the perpendicular bisector that we've proven already. So if I connect D to A and D to B, they are going to be congruent because any point on a perpendicular bisector is equidistant to the endpoints of the segment. Okay, so DA and DB are going to be congruent to each other. And then DB and DC are also going to be congruent to each other because, again, any point on the perpendicular bisector is equidistant to the endpoints, and we've proven that before. So that means that these segments, DA, DB, and DC, are all congruent segments, so they're the radius of the circle, and therefore, since they're the same distance from this one point, then that point, by definition, is the center of the circle. So DA is equal to DB, and DB is equal to DC because the perpendicular of a bisector of a segment contains all points equidistant, which remember that just means equal distance from the endpoints of the segment. And so point D then is the center of our circle that contains B, A, B, and C by definition of a circle because they're all the same distance from that one point. And so by definition, it's the center of the circle. All right, this just says, how would knowing to find the center be useful? If you, we can think of all different cases, but if you were trying to figure out, where to place, I don't know, a stake so that your dog had plenty of room, to run. So like here, if I put the stake here, it's not going to have room. It could go on, right here, it could still extend past maybe the yard. I think of like an invisible fence or something, and it had a transmitter. Okay, it could go outside, maybe in the neighbor's yard, and we wouldn't want that. So being able to find the center of the circle would be important in that case. All right, so you do have a quiz over topic 18 that you will take now. If you are an online learner, then you will have your designated time to take that.